This video is going to examine the scale tool and some of the options you have as far as using it. So you're going to scale components. So we've got a couple components here. We've got a dormer and we've got this cube. Now there's a few ways you can scale an object. Now the first thing you can do is you can key in the scale that you want to adjust. Now let's look here. We've got the measurements here. So it's 10 by 10. Now let's say I want to adjust this length to 20. You have to remember scaling is a factor. It's not a measurement. So if I want this to be 20, I've got to scale this by a factor of 2. So 2 times 10 is 20. So I'm going to grab this cube right here. I'm going to left click once. And I can start dragging it out, and then I'm going to type in 2, enter. And you'll see that the actual dimension, because I put dimensions in, is adjusted as well. So that's one way to do it. So we're keying it in. And we're keying it in by a factor of, or a multiple of. Now, one of the scenarios you might run into that would cause you to have to adjust the scale would be if you're placing something on top of something. Like let's say we've imported this and we're going to place it here, but we want to make it fit. So one thing you can do is, obviously you can mathematically calculate this, luckily this is an easy one. 2 times 10 is 20, but if it wasn't something that was mathematically easy, the other option you can go for is you can scale and you can click on an endpoint. Oops. There we go. We grab that endpoint, or in this case it says on edge. So we'll left click again, and now we've got 20. So that's kind of like the first, more or less, those are the two easy ways to do it. Now this technique is a little more complex and does require some basic math. So this is a dormer, and we're going to attach it to what's essentially a room, or this cube is more or less representing a room. And if we look at the length of this, it's 16 feet 4 and 13/16 inches. If we look at the length of the simulated room, it's 30 feet. So the math isn't quite as easy as the previous situation where 2 times 10 is 20. There you go. So we're going to have to use some basic math. So if we look at the math involved in this, so 1 foot equals 12 inches. That's a constant. Now we're going to convert this into decimals. If you've got a calculator, or either on your computer or a handheld calculator that is capable of manipulating actual fractions, by all means feel free to use it. If you don't, we're going to show how to convert everything into decimal, and we're going to go through the decimal procedure. So we have our 16, 4, and 13/16, and we're going to go 16 feet times 12 inches, which is 192. Our 4 inches stays the same. Now our fraction is 13 divided by 16. That'll give us our decimal point 8125. So we add all these together, got them in a nice row, and we're going to get a working number of 196.8125. Now our simulated room, which is 30 feet, 30 times 12 is 360. So the calculation, our scale calculation, we're going to have to take 360 divided by 196.8125. Now, previously, I used 3 decimal places, which is 1.829. What I did is I more or less kind of shaved it down a bit. Now, when I used 3 decimal places, what it did was it omitted a 1/16 of an inch, so it wasn't perfect. So to get this perfect, we're going to have to add a few more. Now if we go back here and we actually look at the calculator, this is the long form. Now you're obviously not going to have to put this many decimal spots in. But let's look at this. So it's 1.829152. So let's try and remember that. 1.829152. Okay. 1.829152. Okay. Let's see what that says. Now it actually says 30 feet. If you use only 3 decimal places, it's not going to say 30 feet. It's going to be shy by 1/16. Now the preamble of this exercise was to show how to make this perfect. So now what you could do is you could grab it by the corner, and you could go over here and you could just drop it off at your intersection point. If we can get over there, like so. There we go. And got a perfect fit over there. And a perfect fit here. That's it for scale.